Assalamu alaikum class. So sorry, we just ended, the time had ended, so we had to be disconnected. I'll go through this diagram again for your ease. So the process diagram for cascading responses of increased carbon dioxide throughout the environment. So most people know that an increase in atmospheric CO2 leads to global warming, but this phenomena is far from a simple cause and effect relationship. Increased CO2 may cause a cascade of interacting responses throughout the Earth systems. Okay, so it can have a cyclical effect. So we'll see how this feedback loop and cyclical effect works. So number one, coral bleaching. So as a result of increased CO2 in the atmosphere or on the ocean, so we'll see how it affects our atmosphere and the ocean. So first of all, let's see how it affects the oceans. So increased CO2 in the oceans leads to dissolved CO2 in the ocean increase. ठीक है, dissolved CO2 increase हो जाती है ocean के अंदर. जो dissolved CO2 है वो increase होने की वजह से changes in the ocean chemistry occurs. Okay, so the ocean becomes more acidic. So ocean जब ज्यादा acidic हो जाता है, it just starts to dissolve the shells of the corals and the shells of the marine animals. Okay, so it starts to harm the corals because उनकी bleaching शुरू हो जाती है, और जो marine creatures हैं, they lose their shells because they need some certain chemicals to build their shells, and as a result of the acidification, their shell actually dissolves in the water and they are not able to build their shells. So as a result, changes in the ocean food web, because जो corals हैं ये भी degrade हो जाते हैं, जो basic breeding grounds हैं for several fish, and the certain species that have to build their shells, they are also destroyed. As a result, increased extinction events occur. And then as a increase in atmospheric CO2 leads to climate warming. Now the atmospheric effects of CO2. Climate warming की वजह से changes in the precipitation pattern occur. Precipitation patterns basically means rain patterns. सो अब लैंड एनिमल्स के ऊपर क्या होता है, प्लांट्स और एनिमल्स के ऊपर इफेक्ट इसका. सो चेंजेस इन द प्लांट ग्रोथ एज प्रेसिपिटेशन चेंजेस, कि एक एरिया में बारिश ज्यादा हो रही है, एक एरिया में कम हो रही है. सो देयर एक्चुअली नेचुरल केमिस्ट्री चेंजेस. सो एज अ रिजल्ट, the certain plants that were first suitable in our area are no longer suitable in that area because of change in precipitation. या फिर कोई और invasive species हो सकती है किसी और एरिया की, that might come in because now the atmosphere is more suited to them as compared to the native species. As a result, native plants communities, they just decompose, they just degrade, and as a result, a new community emerges of non-native plants. And due to this, the advantage that the native animals had over this community composition, animal community composition, is lost. So now non-native species might be more suitable to this ecology as well, and native species might get destroyed. Then changes in terrestrial food web as a result of this occurs because the terrestrial food web is now destroyed. Native species cannot sustain themselves any longer, and increased extinction events occur on land as well in plants and animals. Moving forward, it also results in the melting of the Arctic tundra. That is also associated with the release of the methane, CH4. So I had already discussed with you that CH4 is 10 times more dangerous than CO2 in trapping sun's heat. So in trapping the infrared radiation from the sun. As a result, global warming. However, how do we release? We do not release natural methane, CH4, into the atmosphere directly. It is released into the atmosphere due to the melting of the Arctic tundra, because under the Arctic there is a huge permafrost that was frozen and that was compressed over the years, several thousand years ago. And as a result, a lot of gas, it has turned into gas, and it has been trapped under the sea ice of the Arctic. As the Arctic tundra melts, most of this methane is released back into the atmosphere, and this triggers the last cycle where a positive feedback loop such as release of the methane from the melting tundra results in accelerated climate change, and this starts the whole process over again. और ये पूरा साइकिल चल पड़ता है इस तरह से. Moving forward, recommendation 5, design sustainable cities. Okay, so for example, at the beginning of the industrial revolution in approximately 1800s, only 3% of the world's people lived in cities, and 97% were rural, living on farms and in small towns. In the 2 centuries since then, population distribution has changed radically towards the cities. More people live in Mexico City today than were living in all the cities of the world 200 years ago. This is a staggering difference in the way people live. Over 50% of the world's population now lives in cities, and the percentage continues to grow. In industrialized countries such as the United States and Canada, almost 80% of people live in cities. City planners around the world are trying to, a variety of approaches to make cities more livable. Many cities are developing urban transportation systems to reduce the use of cars and the problems associated with them, such as congested roads, large areas devoted to parking, and air pollution. Urban transportation ranges from mass transit, subways, and light rail systems to pedestrian and bicycle pathways. So investing in urban transportation is a way other than building more highways encourages commuters to use forms of transport other than automobiles. To encourage mass transit, some cities also tax people using highways into and out of cities during busy hours. Okay, the case study. The Laos Plateau in China. The Laos Plateau covers about 640,000 kilometers, that is 247,000 miles in east central China. This is square kilometers and square miles. Okay. This area is named for Laos, the fine grained, silty soil deposits there by windstorms following the retreat of Ice Age glaciers. Laos, pronounced as Lus in the United States, is deprived from a German word meaning is derived from a German word meaning loose. Loess is a fine-grained sedimentary deposit found in many areas of the world. However, it is thickest and most extensive in China. The Loess Plateau covers much of the North China Plain, and to the west, the hilly basins of the Yellow River. It averages 75 meters, that is 250 feet thick. The loess, which is thick and fertile, was at one time an important resource for China. It provided a fertile agricultural soil that fed millions of people. Chinese people also dug homes in the loess. These homes were cool in summer and warm in winter, although they were prone to collapse from earthquakes. Loess is easily eroded by wind and water, particularly when vegetation is removed from the surface. The Loess Plateau is smeared, so water is often in short supply. Lack of water, in combination with centuries of deforestation and overgrazing, turned much of the Loess Plateau into a non-productive desert. In 1994, the Loess Plateau Watershed Rehabilitation Project was established to reclaim the land from encroaching desert. Portions of the Loess Plateau were reforested. So, see, you can see the photograph. Chinese people living in the area were educated about the cause and of land degradation and encouraged to keep their livestock in pens instead of allowing the animals to roam freely and overgraze the land. As portions of the Loess Plateau have slowly recovered, it is turning green again and less silt is washing into the Yellow River. So over here you can see that all this plateau was reformulated and trees were planted again on its banks. Okay, so that all this plateau has the trees again because it's quite a lot deep. So uh, a lot of potential. This area has a lot of potential. So it could provide a lot of food or lot of for animals, but if it is used properly, and again, erosion would not be possible if the trees are there. Environmental Chapter 3, Environmental History, Politics and Economics. Renewable Energy Policy Challenges. For the past 20 years, governments have struggled to develop climate change policy. Both the costs and of reducing climate change and the effect of not doing so are huge, highly uncertain, and spread out over time, space, and people. And while the scientific community agrees that human caused climate change is happening and will worsen, many people in the United States, among them influential policymakers, remain deeply skeptical. Among the best issue biggest issues in the climate debate is how to shift to alternative energy sources. Fossil fuels, coal, oil, and natural gas are by far the largest sources of the greenhouse gases that are changing our climate. Since 2011, while the cost of coal and oil are high and rising, the cost of natural gas has dropped. For these and other reasons, the United States produces less energy from renewable resources than do several other countries. Finding sustainable locations for alternatives can be a daunting policy challenge. A solar installation can require large amounts of space. In Germany, a town trying to maintain its medieval character is concerned that a proposed solar project will damage its tourism industry. Some California lawmakers object to solar panels in a wilderness area, while in Nevada, concerns about endangered desert turtles habitat may limit installation of site option. Elsewhere, is aesthetics, noise, and environmental concerns threaten the launch of potential wind farm projects. This chapter explores how environmental policy making requires attention to ethics, economics, culture, and politics, as well as to science. Now, the important concept that we are going to discuss today are conservation and preservation of resources. Resources are any part of the natural environment used to promote and the welfare of people or other species. For example of resources include air, water, soil, forests, minerals, and wildlife. Conservation is the sensible and careful management of natural resources. Humans have practiced conservation of natural resources for thousands of years. More than 3,000 years ago, the Phoenix traced hilly farmlands to prevent soil erosion. More than 2,000 years ago, the Greek practiced crop rotation to minimize yields on farmland, to maintain yields on farmlands, and the Romans practiced irrigation. So conservation, you can see that, and preservation in figure 3.1. In figure A, you can see plowing and planting fields in curves that conform to the natural contours of the land, conserving soil by reducing erosion. So if you you plow land in a way that it goes with the natural contouring of the land, it would preserve its erosion. It would reduce its erosion. In B, you can see the Eduardo Everao Andean Fauna Natural Reserve in Bolivia preserves flamingos and other wildlife populations and their habitats, such as this one on Laguna, Colorado. Okay, environmental history. Uh, so we need to protect the forests. Okay, this is important. Utilitarian conservationists, a person who values natural resources because of their usefulness to humans, but uses them sensibly and carefully. So this is a nice concept, interesting concept, that where we value our natural resources because of their usefulness to humans, but we still use them sustainably and carefully rather than unsustainably. So these movements, just they all sprung up. Let me go from here. From the establishment of the first permanent English colony at Jamestown, Virginia in 1607, the first 2 centuries of the US history were a time of widespread environmental destruction. European settlers exploited land, timber, wildlife, rich soil, clean water, and other resources that had been used sustainably by native people for thousands of years. The settlers did not recognize that the bountiful natural resources of North America would one day become scarce. During the 1700s and most of the 1800s, many Americans had a frontliner attitude, a desire to conquer nature and put its resources to use in the most lucrative manner possible. Two characteristics of the European settlers and their descendants drove this unsustainable resource use: rapid population growth and high per person consumption. European settlers tended to be more densely populated than those of natives, and settlers accumulated more permanent material goods: houses, roads, wagons, furniture, tools, and clothing. The great forests of the northeast were cut down within a few generations of European settlement, and shortly after the Civil War in the 1860s, loggers began deforesting the Midwest at an alarming rate. Within 40 years, they had deforested an area the size of Europe, stripping Minnesota, Michigan, and Wisconsin of virgin forests. By 1897, the sawmill of Michigan had produced 160 billion board feet of white pine, leaving less than 6 billion board feet standing in the whole state. Now, the establishment of national parks and monuments, based on all this degradation, the national parks monuments establishing were established by the Congress. Congress established the world's first national park in 1872 after a party of um, uh, Montana explorers reported on the natural beauty of the canyon and falls of the Yellowstone River. Yellowstone National Park was includes parts of the Idaho, Montana, and Wyoming. In 1890, the Yellowknife National Park bill established the Yellowstone and Sequoia National Park in California, largely in response to the effect of a single man, naturalist and writer John Muir. So you can see the Hedge Hetchy Valley in the Yellowstone in figure 3.4. Okay, discussing the biocentric preservationist, a person who believes in protecting natural nature from human interference because all forms of life deserve respect and consideration. And now the systems perspective, a perspective that considers not just immediate or intended effect of activities, but all of the impacts of those activities in other places or at other times. Then came in the environmental movement. Until the 1970s, the voice of environmentalist people concerned about the environment was heard in the United States primarily through societies such as the Sierra Club, and the National Wildlife Federation. There was no generally perceived environmental movement until the spring of 1970, when Gaylord Nelson, former senator of Wisconsin, urged Harvard graduate students Denise Hayes to organize the first nationally celebrated Earth Day. This event awakened US environmental consciousness to population growth, overuse of resources, and population and pollution and degradation of the environment. On Earth Day 1970, an estimated 20 million people in the United States planted trees, cleaned roadsides and riverbanks, and marched in parades to support improvement in resource conservation and environmental quality. In the years that followed the first Earth Day, environmental awareness and the belief that individual actions could repair the damage humans were doing to Earth because became a popular movement. So the timeline of the selected environmental events from 1970s to the present, you can see it in figure 3.9, the first Earth Day and how it moved on from there onwards, and how different species were preserved and how different acts were passed. Environmental discovery in environmental literacy, because responses to environmental problems depend on the public's awareness and understanding of the issues and the underlying scientific concepts involved. Environmental education is critical to appropriate decision making. The emphasis on environmental education has grown dramatically over the years. Prepared by coursework at their schools. Almost 1 lakh US high school students in 2011 took the College Board Advanced Placement Exam in Environmental Sciences, a test accepted by approximately 1,700 colleges. More than 30 states required some form of environmental education in primary and secondary schools. In 2012, the National Council for Science and the Environment launched the Climate Adaptation and Mitigation e-learning portal to provide curricular resources for climate educators. In 2009, the Association of Environmental Studies and Sciences was founded to support colleges and universities, faculty, and students. So all this process, how this happened, and all the environmental legislation. And what is the environmental impact statement, figure 3.10? So major construction projects proposed, environmental impact statements prepared, and EIS released to public review and committees commitment. Comment, okay, based on public debate, the project may proceed as planned, proceed with modification, be sent back for further development, or be withdrawn. So these are all the environmental regulations that have been placed in the United States. So I'm not going to go into much depth in them and how they have and what they have accomplished in the United States. Environmental economics. Okay, so this economies depend on the natural environment as sources for raw material and sink for waste products. Both sources and sinks contribute to natural capital. Now, what is natural capital? Natural capital is the earth's resources and processes that sustain living organisms, including humans, including minerals, forests, soil, water, clean air, wildlife, and fisheries. National income accounts and the environment. Ideally, for the purpose of economic and environmental planning, national income accounts should include natural resource depletion and environmental degradation. Uh, Two measures used in national income accounting are gross domestic product and the net domestic product. A national income account measure of the total income of a nation's goods and services for a given year. We've already discussed this in chapter 1 in the previous from the previous book, so that is why I'm not going to go into detail with these. Figure 3.15 shows the population cleanup, so the pollution cleanup and GDP. Air emissions from chemical plants like this one in Cleveland, Ohio, number A, are far lower than they would be absent air quality in the absence of air quality regulations. The costs associated with controlling air pollution from industry, transportation, and other sectors are far smaller than are the resulting benefits to health, property, and the environment. Number B, improved air quality is not included in the calculation of the GDP. So you can see that the costs were much lower than the benefits associated with these air quality emission regulations. An economist's view of pollution. An important aspect of operation of a free market system is that the person consuming a product should pay for all the costs of producing it. However, production or consumption of a product often has an external cost. Now, what is the external cost? A harmful environmental or social cost that is borne by people not directly involved in selling or buying a product. A product's market price does not usually reflect an external cost. This is the buyer or sellers don't pay for all of the costs associated with the production. As a result, a market system with externalities generally does not operate in the most efficient way. Okay, now the marginal cost of pollution, the additional cost of an additional unit of pollution is called the marginal cost of pollution. Marginal cost of pollution. Marginal cost of pollution abatement, the additional cost of reducing one unit of a given type of pollution. And the cost benefit diagram, a diagram that helps policymakers make decisions about costs of a particular action and benefits that would occur if that action were implemented. This is the cost benefit diagram. So this is the economically optimum amount of pollution. Optimum amount of pollution, the amount of pollution that is economically most desirable. Economic strategies for pollution control, command and control regulation, pollution control laws that work by setting limits on levels of pollution. Incentive-based regulation, pollution control laws that work by establishing emission targets and providing industries with incentives to reduce emissions. A case study from a tradable permits and acid rain. Many industrial policy experts believe that a cap and trade system is the most promising approach to managing the problem of climate change. They argue that setting a global or national by nation cap on greenhouse gases would encourage people to find inventive and inexpensive ways to reducing emissions. However, incentive based environmental regulations remain less familiar than command and control regulations. The example of tradable sulfur emissions permits. Okay. The example of tradable sulfur, however, incentive-based environmental regulations remain less familiar than command and control regulations. The example of tradable sulfur emissions permits for to reduce the effects of acid rain down demonstrates how effective the approach can be. When coal, when coal contained sulfur When coal containing sulfur is burned, sulfur dioxide is created and released, causing acid rain. See chapter 8. Through the 1970s and 1980s, Environmental Protection Agency EPA regulations require reduce sulfur emissions primarily by mandating command and control system solutions. This meant that many large coal burning power plants had to install specific and often very expensive equipment. By the late 1980s, these facilities knew of less expensive options for reducing sulfur emissions but had no incentive to adopt them. Consequently, the Clean Air Act amendments of the 1990s allowed the EPA to limit the amount of sulfur that could be emitted, with a smaller amount allowed each year and then sell the right to these emissions. Each year, the EPA allows the Chicago Board of Trade to action permits to emit sulfur. Companies may then buy and sell these permits as needed during the year. Industries quickly adopted a variety of technologies such as removing sulfur before burning coal and met the EPA's sulfur reduction goals ahead of schedule and at a lower than expected cost. Tradable permits have not worked as well in all cases. Attempts to reduce water pollution have had mixed results, especially when more than one pollutant is involved. Grandfathering and or exempting older facilities has undermined other efforts. And in the sulfur case, the EPA was able to establish clear goals and accurately measure emissions, both of which may prove a challenge for a greenhouse gas cap and trade systems. Nevertheless, the success of tradable sulfur emissions suggests that incentive based regulation has a promising future. Coal burning power plants in the United States, such as this one in West Virginia, emit sulfur that causes acid rain. Until the 1990s, the EPA mandated emissions control technology. Since the 1990s, companies have had more flexibility in how to reduce their emissions. These buildings in Ottawa or Ontario, Canada, have been damaged by acid rain. This is an example of an externality caused in part by sulfur emissions from coal burning power plants in the United States. So that's it for today, students. Thank you very much. We'll continue in the next lecture.